Okay, so this is the start of Unit 11 notes, which is talking about solutions. You're probably a little bit familiar with solutions. When we're talking about solutions, we're basically talking about a mixture where something is like dissolved into another substance. Okay, so you should have kind of seen on the simulation yesterday, some of these words should be familiar after working through the simulation. But we need to make sure we just kind of know these two basic vocabulary words. So a solvent, that's just basically what's actually like your main substance that you're using to dissolve. So this is usually water. About 99% of the time, it's water. Water is actually called the universal solvent because it can dissolve almost everything. The solute is actually like the substance here that's being dissolved. So if you think about like if you're going to make salt water, the salt would be your solute, and then your solvent is again water. Okay. So when we're talking about solutions, just knowing what the term solubility means is important. That's just the ability for a substance to dissolve. So if I say something's soluble, right, that means it can dissolve. We've used this word before, but this is just kind of making sure we understand what it means. So when we're talking about an ionic substance, that ionic substance is actually going to break apart into ions. So for example, if I have NaCl, like my salt, right, it's a solid. If I put it in my water, what's actually going to happen is I'm going to have these little positive sodium ions, and we call it aqueous because it's dissolved now in water. And then we have these little chlorine ions. Okay, so because I have these ions, specifically these nice, pretty negative ions, it actually allows this solution to conduct electricity. We call it a electrolyte now. Okay, so the chlorine, the sodium ions, those are electrolytes because they can conduct electricity. Okay, so that's kind of the reason why you don't swim in a pool when it's thunderstorming or swim in the ocean, right? Is you're much more likely to get struck by lightning because if the water is struck by lightning, that electricity can actually travel through the water to you. A covalent substance, it remains as a whole molecule. So what we're really seeing, I think you have an example for sugar, and you'll see on your notes that it's the same. Nothing breaks apart molecule-wise, right? So like if I put a big scoop of sugar, like let's say it's a cube of sugar, okay, really that's just a whole bunch of individual sugar molecules all packed together, right? Well, when it dissolves, what happens is those sugar molecules, they just kind of separate out, okay, into their little tiny microscopic particles that we can't actually see with our eyes. So it looks like it disappears. It looks like, oh, maybe it's broken down into smaller particles, but it's still a sugar molecule. It's just now they're individual molecules, or maybe one or two molecules together, as opposed to, millions, billions of molecules where we can actually see it. So when we talk about solutions, one thing we can talk about is the concentration, how concentrated a solution is, and that's where we're going to kind of encounter this term molarity. Okay, so you probably know concentrated and dilute. Okay, if you've heard these terms before, think about like if you're going to make Kool-Aid, if I put too much of that red powder in there, if I don't have enough water, I have too much of the red powder, I have a concentrated solution. That's this right here, right? It's really usually a dark color. Sometimes you might even taste where some of that Kool-Aid doesn't even really dissolve in the water all the way. Dilute would be the exact opposite, right? It's where you don't have quite enough Kool-Aid powder. Maybe you added too much water and didn't add enough Kool-Aid. Okay, and these are qualitative measurements. Remember, these are just descriptions. Okay, it's just saying, oh, something's concentrated, something's dilute. I'm just describing the solution. when I want to use a quantitative concentration, remember that's an actual number, we call that molarity. Okay, so one thing to know is the higher the number, okay, the higher the concentration. So the more concentrated, the bigger our number, our molarity is going to be. Okay, and we have a formula, so make sure you write this down in your notes because we're going to do some practice problems here. Okay, we can actually calculate the concentration if we have the amount of our solute and the liters of our total solution, our solvent. Okay, so for example, okay, I know my formula is moles over liters. Okay, and my equation says 0.450 moles of sodium chloride are dissolved in 95 milliliters of water. So here we have milliliters, but in my equation I have liters. Okay, so I have to remember to convert that. Basically, all you really have to do is move your decimal over 3 places to the left, 0.095, or you can just divide by 1,000. Okay, because there's 1,000 milliliters in 1 liter. So once I've done that, I'm just going to type it in my calculator, 0.45 divided by 0.095, and I end up with 4.7. And then we can abbreviate when we're describing the concentration of a solution, we use a capital M, and that M stands for molar. It's kind of a shortened molarity. So I would say that's a 4.7 molar solution. Okay. Here I'm going to do just a couple of these, and then you have the answers here, so you can kind of check yourself as you go through. Number 2 is exactly the same way as number 1. Just make sure you change this to liters. So I'm going to move my decimal over so I can get liters. Okay, so I'm plugging it into the same formula. Number 3, if you notice, I'm giving grams instead of moles. So the first thing I have to do is convert my grams of NaCl to moles of NaCl. So how can I find how many grams are in 1 mole? I'm going to look at my periodic table. Sodium is 22.99, chlorine is 35.45. Sorry, if I add those up, I get 58.44 grams of sodium chloride. Okay, so I'm just going from grams to mole. I'm just dividing by the molar mass. Okay, so once I do that, I can divide, right? Because we multiply the top, divide by the bottom, and I end up with a 0.26 moles of NaCl. Okay, so now I can plug it into my equation. Moles over liters. So 0.26 moles over, remember liters, I have to turn it into liters from milliliters. So I'm just going to move my decimal over, and then when I type this in my calculator, okay, I get 0.26. I typed a number in wrong. I get 46666, so it rounds to 3.5 because of my 2 sig figs. And again, molar with a capital M. Okay. Number 4 is just like number 1 and 2. Number 5 is just like numbers 1 and 2. I'm given moles over liters. Okay. 6 and 7 are again, I have grams. So I have to do something with the grams. So if I look at number 6, in this case, I'm actually given my molarity, and I'm looking for the volume. Okay, so in this case, I still need to convert to moles. So 45 grams. How am I going to find how many grams are in 1 mole? Right, I have to add it up. So calcium is 40. We'll just do a roundabout estimate. 14 is nitrogen, but there's 2 of them. Oxygen is 16, but there's 6 of them. Comes out to be 164. So when I divide, I get about a 0.27. So if I'm looking at this formula, moles over liter, right, I can plug in 1.3, that's my molarity, equals 0.27 moles, and I'm looking for liters. Okay. So I kind of have to go a roundabout way to solve this. So I could do it a couple different ways. I could just pretend like that's over 1. I can cross multiply, so I end up with 1.3 times L liters is just equal to 0.27. And then I can divide by 1.3. And then I end up with, it says like 0.21 or 0.207. It's okay if you round liters. And so all I've done here is I just turned it into milliliters. So if I wanted it to be in milliliters, right, 207 liters is the same thing as 207 milliliters. I just moved my decimal back towards the right. So it's okay if you want to leave it in liters, 0.207. It's just, we turn it back into milliliters sometimes. You'll see that because if I was going to actually measure it, my graduated cylinders use milliliters. They don't measure in decimals. So that's the reason we turned it back. Okay, number 7 is more straightforward. You just have grams. You have to go grams to moles, and then you're just plugging it in, moles over your liters. So you'll turn this number back into your liters. So 0.2892. Okay, so you should get that answer. One last little part of this topic is talking about dilutions. So we use this, I actually make dilutions all the time for this substance, for the different substances that we use in our labs. A lot of times the chemicals that we buy, they're very concentrated. And then they do that so that you, like me, I can buy some solution that's very concentrated, and then I can just add water to different amounts, and I can make a whole bunch of different molarities, different dilutions of different concentrations of the same substance, okay, as opposed to buying something that's a 2 molar solution, a 4 molar solution, a 6 molar solution. It's a lot cheaper to do it this way. So we actually do this all the time. Basically all you do is you just add water. So we're just kind of figuring out how much water do we need to add to this starting solution. So I have a starting solution. I'm going to add some water, okay? And then this is my ending solution. So this is like the final concentration I'm trying to make, okay? So we have a formula, this M1V1. So this is like our start, right? What we're starting with. And then again, this is our ending, just like in the picture above, okay? And the V, one thing to keep in mind is this V is really our total volume, okay? So this is our total volume at the end and our total volume at the beginning. And I'll show you what I mean by that. Okay, so this volume is not telling you how much water you're adding. It's telling you how much you actually have of your solution. And then I can take the difference and find my water. Okay, so for example, okay, it says, how would you prepare 60 milliliters of a 2 molar nitric acid solution from a stock solution of 4? Okay, so what it's saying is I'm trying to make this, so this is like my end, okay, and I have this. This is my start. So I'm just going to plug it in. Okay, so my start of my M is 4. I don't know my volume. That's what I'm trying to figure out. I need to know how much of this am I going to add, how much of my start, and then my ending, 2, and then 60. For this formula, it's okay to leave it as milliliters because my answer I can also have in milliliters, okay? So I don't have to change this to liters. So I'm just going to multiply, right, 2 times 60, divide both sides by 4, and I get 30. So what this is saying is that I need 30 milliliters of this starting solution. So if I have my little graduated cylinder over here, there's my 30, right? I'm just going to add 30 milliliters of my starting solution. Okay, but it says I want to make 60 milliliters of this, of my ending solution. So what I'm gonna do is actually add water until I get to my 60. Okay, and then of course that'll mix up, so I'm diluting this original solution down. It kind of all mixes together with the water. Okay, let's look at one more. So it says if I have a 50 milliliters of a 2 molar solution, okay, how many milliliters do I need to add? So basically, like, how many milliliters of water do I need to add to dilute it to a 1.5? So this is my end, and this is my start. This is what I have. So M1V1, M2V2. So M1, I have 2 molar, and I have 50 milliliters. Okay, my ending, I have 1.5 molar, and I'm looking for that volume. Okay, so when I multiply this out, divide by 1.5, I end up with about, let's say 67. We'll just round it to make it easier. 67 milliliters is my volume. Okay, and remember we said this is my total volume. So this is like saying, okay, well, if I have a graduated cylinder, right, my total volume is going to be 67 milliliters at the end, right? Because this is my end, V2. So my total at the end is 67. Okay, so what did I start with? I started with 50. So let's say right here is 50. So this is my starting solution up to 50. Okay, so how much water did I need to add to get to 67? Okay, and it's 17 milliliters. Okay, if you can get to this point, that's totally fine with me. If you can tell me my final volume needs to be 67, that's good for me. Okay, this is kind of the extra step over here, is going back and kind of seeing how much water do I need to add to dilute it, right? So that's the end of this this unit. You do have a little homework module that's not too bad. So just email me if you